All right, so the linear inequalities, that's what we've got up here to start. We solve just like if it was equals, okay? But like I said here, we're going to solve and graph our solutions. So just like we always do, we want to get x by itself. So we're going to add 5 first. And then divide by 3. Now remember, with inequalities, sometimes we have to switch our inequality symbol. This time we did. You guys remember when we have to switch it around? Lori? Right. If that was a negative 3x and I divided by negative 3, I'd have to switch my inequality symbol around. Okay. Also, if you multiply by a negative. So if you divide or multiply by a negative number, both sides, you're going to switch your inequality symbol. All right. So when we graph it then, you don't have to do some huge number line. Whatever our number is, I always put in the middle. And then I go 1 to the left and 1 to the right. And then I draw a little graph on here. Now, since it says less than or equal to, that means we're including the 4. So we put a solid dot on 4. That means we're including it. If that equal to wasn't there, I'd put a circle on 4, meaning I'm not including the 4. Okay? And less than would be this way, towards 3, 2, 1, and the negatives, right? So it's just a little inequality that you draw to go along with or a little graph to go along with your inequality once you got it solved. Okay, if you're just getting x by itself. So these linear ones are pretty easy. Okay, so here, again, subtract 8. I want to get the x alone. And that's 6. And this time we're dividing by negative 2. So we got to remember to switch it around. And then x is less than or equal to negative 3. So on our graph, put negative 3 here. So negative 4 would be here, and negative 2 would be here. All right, again, since it's got the equal to, it's a solid dot, and less than would be to the left, towards the smaller. This is saying all the numbers less than or equal to negative 3. So the ones to the left of negative 3 are the ones that are less than it. Maureen Tatum. Thanks. Any questions on those first two? They're pretty easy. See balloons. So those are the linear ones. Your basic, like algebra 1 stuff, right? We also have compound inequalities where we put more than one in there, 2 or more. All right, this one's already separated. Sometimes they're not separated. I'll show you one here. This one, they're not separated, but I'll show you what we do there. But these are already separated, and we just solve them, okay? I want to get x by itself, so we're going to divide by 4, because it's 4 times x there. So we get negative 2, x is less than or equal to negative 2. Here, I want to take the 1 over to the other side, or by subtracting it. That's negative 6, and then we're going to divide by negative 2. So we got to remember to switch our inequality symbol. Okay, and then we graph that. Now, when it's an and like this, all right, when it's an and, you want to see where they overlap. When it's an or, you just put them together, all right? So if it's an and compound, basically what's common, we're thinking, where they overlap on your, when it's an or, you just put them together, the two together, when you graph it, okay? So we're going to graph this. again, you don't have to put all the numbers, negative 2 is going to be down here, 0 is about there, and then 3 is up here. Okay? So if I look at this first one, I'll do that in green, I would make a solid dot and go to the left. Okay? I'll do this one in blue. I'd make a solid dot at 3 and go to the left. Since it's an and, where do they overlap? What do they have in common? From the negative 2 on, right? So, the graph that covers both of these would be from here, the red one, from negative 2 on, because it's what they have in common. It has to work for both. 0 is less than 3, but it's not, it's not less than or equal. And then when it says and, we got to find all the numbers that are less than or equal to negative 2 and less than or equal to 3, which are all the ones over here. Does that make sense?
For Owen column.
Right there. You guys understand that? If it was or, if it said or between those two, I would just put them together. All right? And then it would have been the blue one, actually. If it's an or, this has to work for one or the other. Okay? So if we were to do the graph and that was changed to or, it would have been from 3 this way. Because, let's say we pick 2. 2 is less than or equal to 3. It's an or. It doesn't have to be less than or equal to 2, right? It has to work for one or the other. All right, so sometimes you'll see ors, sometimes you'll see ands. Okay? When we do the absolute value ones here in a few minutes, I'll tell you how to tell if it's an and or an or. Questions so far? When you have one like this, where it's just put together, a couple ways you can do it. You can write it as 2 separate problems, okay? You could do that problem and just write it and do it like you've been doing. And then you could do this problem and write it. Okay? You can write it separate, as 2 separate, and when they're less than, always put a D on the end. That makes it a and problem. Okay? If it was greater, I always, instead of saying ER, I go OR. Boys having trouble waking up today, huh? It's good to have you guys. All we need was Allie and Maddie to show up too. All right, so that's how I think about less than. It's an and problem. Greater is an or problem. That's what I go by. So you can do them separate, and all you're going to do is subtract 5, right? Right, Bars? Both times, no matter which one you're doing, the purple one or the green one, you're going to subtract 5 from both sides. Then you're done, right? You guys with me on that? You could also do this. You don't have to write them twice. Separate. Okay, if you want to get this x alone, you're going to subtract 5. So you're used to doing whatever you do to one side, you do the other. Well, if you're doing it to the middle, you got to also do it to both ends. So you could just keep it like that if you want. Just make sure you do it to everything, whatever you did to get x alone. Okay, so you can write them separate if you want, or you can do it like this. And then you're done. You just got to do your graph now. So again, I just put, since there's a couple, I just put 7 and 14. Usually I pick a number in between, let's just pick 10. Doesn't matter what you pick, but pick a number between. All right. And then, Since it's less than or equal to, all right, you're going to put solid dot at each one because of the equal to. I should have one that didn't have that symbol so you know. Put a circle if the equal to is not there. Right? We haven't had one yet. Now, over here it says x is less than 14, right? So that would be going this way, right? Here this says 7 is less than x. So 7, is it less than 6 or is it less than 10? Right, so it'd go this way, right? You with me on that? So when you have one like this and it's less than, and an and, less than is an and, you just overlap them. That's all the numbers from 7 to 14 would work. You know, if I picked 15, 15 plus 5 is 20. It's not between 19 and 12, right? If I picked 10, all right, or I mean 6, 6 plus 5 is 11. It's not in between 12 and 17 or 19, right? So what we did is just a graph, remember, is just a picture of all the answers. And that's why we're graphing it, so we can show what it looks like. Okay, so that's a compound. So we got single, basic linear inequalities, all right? Solve for x and then graph. And we got compound where we got more than one problem, more than one thing to do in it, okay? We also have absolute value today, all right? Now, just like before, we did this a few weeks ago, probably 3 now, maybe even a month ago. How many problems did we have when we had an absolute value equation? We had 2 problems, didn't we? Okay. So same thing here. When we have an absolute value inequality, there's 2 problems here. All right. The original, 3x minus 2, less than or equal to 4. And since it's less than, this is an and. So when I graph it, I'm going to see where they overlap. All right. And the other one is 3x minus 2. That part doesn't change. Okay, don't change that part inside the absolute value sign. You change the inequality symbol, and you change the sign of the 4. That's the second problem. All right. So you change the inequality symbol around, flip it, and then you make whatever's over there its opposite, negative. And then you just do what you've been doing. All right, so you're going to add 2. Oops, less than or equal to 6. Divide by 3, so x is less than or equal to 2. Same procedure, add 2. And that's negative 2. Divide by 3. And you get a fraction. And it's okay to get fractions or decimals. Doesn't have to be whole numbers, okay? Not everything's going to work out really nice. That's all right. Nothing wrong with that. So then we're going to graph this on our number line. All right? So 2 would be down here. 0, let's say, would be there. Negative 2/3. Here's negative 1. Negative 2/3 would be like right there, right? And if you just want to put negative 2/3 to the left of 0, that's okay. So at 2, solid dot, because we had the equal to, and going to the left, less than. At negative 2/3, solid dot, because it's got the equal to, and it's saying x is bigger than this. The number's bigger than that, would be going that way. All right, where do the 2 overlap? In between, right? They go towards each other. And that's what happens, most of the time on an and. They usually go towards each other. And the ors usually go opposite each other, but not all the time, but 90-something% of the time, okay? Questions so far? So remember, when it's absolute value, there's two problems you have to do. Okay? Okay, this one, 8 minus 2x, greater than or equal to 6. Since it's greater or 8 minus 2x, again, that doesn't change. Less than or equal to, switch it and make it negative 6. So make the 6 negative and switch your inequality symbol. And then just do them like you've been doing. All right, subtract 8. Divide by negative 2. So remember, when we divide by negative, we got to switch our inequality symbol. And a negative 2 divided by negative 2 is positive 1, right? And then over here, we're going to end up doing the same thing. We're dividing by negative 2 again. So it switches. Now again, since this was greater than, I always like to say greater, so I know it's an or problem. And again, that's just for my graphing on the number line stuff. 1's down here, 7's here. Pick a number in there. Let's just say 4. All right. Greater than or equal to 7. The equal to solid dot. Greater than would be that direction. Less than or equal to 1. Solid dot for the equal to. Less than would be that. That's what usually happens on the ors. They go the opposite direction. Okay. If the ors go towards each other, it means all real numbers are going to work. Okay? If the ands go opposite each other, it's going to mean there's no solution because they don't overlap. And that'll happen once in a while. Not very often. Okay? So, we have 3 types today. Absolute value ones, there's 2 problems. We got compound inequalities, there's 2, but they usually write both of them for you. They'll write them both. Sometimes they'll tell you it's an and or an or. Sometimes they'll do it like that. Less than's an and, greater than's an or. All right, and then they'll, just basic linear ones. Okay? Tomorrow we'll do some quadratic ones. And forget what the other kind was. Oh, fraction ones. Tomorrow we'll do some fraction ones and quadratic ones. All right? So, pretty easy day for you. Lots of time to work on your homework.